All right, everybody, we're going to go ahead and get started. Thank you for joining us today. This is an API First Development webinar focusing on RAML and SOAP UI. This is being co-presented by MuleSoft and SmartBear. Before we get started, a couple of little housekeeping tips. First of all, we are recording. We'll send this to you later this week. If you have any questions or comments throughout, you can tweet us. We'll be watching at SOAP UI and also at MuleSoft. And if you use the hashtag API first, we'll be able to pick up your comments. Also, you can use the chat panel in the webinar if you have any questions. We're going to do Q&A at the end. So if you have questions as we're going along, just type them into the chat box and we'll pick them up at the end and direct them to our presenters. And speaking of our presenters, so today we have Sumit Sharma from MuleSoft, and we also have Ulla Lensmar from SmartBear.
Hi, everyone.
Hello.
All right, so we're going to start with a bit of a focus on RAML, and then we're going to move over and take a look at some of the other capabilities and also some stuff that you can do in SOAP UI. So I'm going to start with Sumit. Sumit, I'm going to hand this over to you, my friend.
Great. Thank you, Lorinda. Hi, everybody. Thank you for joining our webinar this morning. And for those of you in the East Coast, good afternoon, or in Europe, good evening. So, this is a very interesting topic about API first. And, you can, when all the developers, most of the developers I've talked to over the last few years, there's this notion that APIs are broken. And, there's many reasons for that. But, I'd like to think that one of the reasons is because APIs have not been designed with the consumer in mind. They have not been designed with, what purposes, what a very conscious, deliberate kind of intention around what purpose and how it's solving a problem. And so, one of the things I'd really like to talk about is how, API design should actually follow some sort of a life cycle. And it's not too different from the way software is designed today. And, how you should care about certain tooling that helps you in that design life cycle, such as being able to design and mock the API. And at the end of the day, basically, APIs are about machine-to-machine communication. But at the end of the day, when you're designing these APIs, at the end of the day, we're solving human problems, we're solving business issues. And so that notion of inserting humans into the process of API design becomes very important. And so, one of the things I'm going to talk about is how can we insert humans into this process, and what is that language that will allow humans to be able to communicate efficiently around how an API should look. And at the end of the day, it's going to be about keeping things simple, keeping that language simple. And so that's sort of what I'm going to be touching on in the next few minutes. And it all boils down to this notion of, I always think of let's say the iPhone came out, or any kind of product that came out when it was, something that really struck you with a good user interface. One of the things that struck me when something like the iPhone came out was that it had a really good user interface, and it was super disruptive for that reason. And, the same principle applies in my mind to how software works, and it should also apply to how APIs are. And, oftentimes we as developers, we develop APIs and we think or we hope we have the right API. We hope that it's solving the right problems in the right ways, and we're hoping that, we want that validation. But sometimes we aren't able to get that validation. And so it really is changing our paradigm about how, when we design APIs, it's about moving from a inside-out perspective, which is basically saying, hey, I'm going to code up my API and, do it from the server side first, and maybe if I'm using Java, I might use JAX-RS, Jersey annotations, right? And then kind of expose my interface as an afterthought, or as people commonly say, I want to build my application first and then slap on the API. And that approach obviously is not optimal for having that optimal user experience for the API. And so this notion of outside in versus inside out comes in where The old way is kind of inside out, and I think learned if you click next, you'll see, and the new way is outside in, which is basically saying, guys, let's really incorporate a feedback loop and a mechanism in our design lifecycle that allows us to design our APIs outside in. And what that means is, moving away from this paradigm of implementation first to the interface. And so it's separating two concerns. There's an interface and there's an implementation. Next slide, please. And so the difference, so to do that, there's this design lifecycle that I just mentioned, and it's not too different from the way we operate in a software lifecycle, or when we're trying to design anything like a product. And at the end of the day, your API is like a product, and it is now becoming a first-class citizen. If it already hasn't, it will be. And one of the reasons for that is we're in a world where I believe that APIs are going to become like a currency of conversation. And one of the reasons is because everything's getting so fragmented. Internally, we're trying to really create loosely coupled systems. We're trying to get more service orientation, or externally, maybe from a B2B perspective, we're really finding new ways to collaborate and exchange data with our B2B partners, or the way we interact with our customers. There's more dynamic ways of interfacing with customers. So all of that is going to entail for us to kind of be really fast and nimble with how we approach APIs. And for us to be really successful, we really need to look at this notion of APIs being designed for the user in mind. And so this notion of user experience, what user experience was to an application, is what APX is to an API. So that's what we call APX, which is basically that notion of good user experience for an API. And so this whole design lifecycle is kind of optimized for designing with a user in mind, and designing with the notion that you want to be able to kind of mock up an interface and be able to sort of say, okay, this is what my API is going to look like. This is what my API is going to behave like. These are the resources. These are the methods. This is what the responses are going to look like. And you want to be able to validate that. At the end of the day, we want to make sure we're not in a silo, and we're not just developing something that we think and hope is going to be the right thing. And so we want to validate it and fail fast. And so you want to be able to kind of quickly validate it, mock it up, iterate really quickly, capture feedback, go back to square one, and move on and kind of just iterate and fail fast and iterate. And so being able to kind of cleanly and easily mock up your API, model the interface, what it's going to do, without even touching the implementation. This is just about kind of separating the concerns of interface and implementation. So you're able to say, okay, this is what my API is going to look like. I've modeled it nicely, cleanly, and being able to kind of put that out there for reaction. Another thing that I'd like to touch upon is modeling your API consistently. And any well-designed API out there is, no matter, probably the better designed an API is, the more repetition we'll actually see. Because at the end of the day, we want APIs to be intuitive. We want to be predictable for our developers to understand. And so, maybe we'll define a collection, and we'll find that, it just so happens that our collections in our APIs all have gets and post methods. And it just may be that some sub-collection items, like some sub-resources, will have get methods. And, and the way the responses are, let's say, for example, the descriptions in a response code from all the way from 200 all the way to 500, maybe the descriptions are going to be sort of in a very predictable way. And you want to kind of describe our API, our responses in a very consistent way. And so what we'll find is that there's sort of patterns occurring in our API where, we will have things like structural patterns at the API level and patterns at the method level. And so it's very important to be able to kind of model your API interface in a consistent way so that you avoid repetition and unnecessary heavy lifting, because you're going to be finding that as you model your API interface, as I will show you, you'll be able to kind of encapsulate patterns. And B, you want to make this, as shareable and as collaborative as possible. So imagine in a world where you're modeling interfaces in an API in your company, and you want to kind of standardize on how certain response codes are going to be, or how certain get methods, query parameters are going to be defined. So it's a good way to kind of share standards within your API design process. So modeling your API is all about sort of, to summarize, it's really about following a formalized API design lifecycle so that you're able to kind of say, this is what my API interface looks like in a very clean and consistent manner. So you've modeled your interface using patterns. And then this is what people think. So you're going to mock it up. You're going to validate it and see what they think and capture that feedback. And eventually, once you're ready to go to production, you'll put it out there for people to digest and use. And this is where Ole will come in with some more things you can do. So the next slide, please. So I'd love to just share a true story of exactly sort of a similar conversation that Ole and I actually had a while ago when I was sharing an API with Ole. And, this is a great testament to this design lifecycle in action, where actually what I did was I created an interface with the API when we kind of created and we mocked it up, which I'll show you soon. And, I said, okay, Ole, here's the mock version. And Ole actually was, he saw it. He kind of played around with it. He was able to kind of look at what the responses were going to be and how the methods were structured and the query parameters. And he actually was wondering, well, is there a way to give the response in a different way so that he can actually paginate and actually digest the results, let's say 20 to 30 of 98, so that he can actually selectively kind of just parse results. And so what we did was we added an output parameter, and that actually satisfied his need. And so that was a great way for me to not kind of work from, I did not have to implement the API in the back end for this. This was literally from an interface that we had this whole conversation, and we iterated over that interface or that contract of the API until we came to a good sounding board, a good kind of mutual benefit there. So, Ole, do you have anything to say about this?
Well, definitely when we move forward and start looking at the actual tools, I mean, we've been using the RAML tools that you're going to be showing in a while in a couple of our projects ourselves, and especially having this possibility to easily, iteratively improve on the API design by adding new constructs, creating mocks quickly and just trying them out makes it so much easier to come up with something up front, which actually is something that's going to at least partially resemble what you'll get out in the end. I think that it's extremely important.
Right. Exactly. And so, the notion is that to be able to do this, whenever I have an idea, and I'm sure whenever a lot of us have ideas, one of the things we do is we go on a whiteboard, right? We go and we kind of sketch it out, and we say, hey, guys, let's visually look at what this is going to look like, and whatever the idea is, and then you guys will talk about it, right? So you'll have a whiteboard and you'll kind of ideate together. Now, what if we could actually whiteboard an API? And what does that actually even mean? And so, and the reason is because, if you're going to try and have this feedback cycle, you need to have that sort of environment where you can actually be able to say, here's what it's going to look like, and here's how it's going to behave. So it's equivalent of whiteboarding an API. And so for that, you need to have some sort of a specification, an API specification that bridges the divide between, the old world or current world of API implementation as the first thing we do, and bridging that between how we define and efficiently define the interface or the contract. And the reason why this is important is because, typically what you do is on the left-hand side first, right? So typically we code first. We will build the API, and like I said, we'd use some annotations to kind of generate maybe the API contract as sort of like an afterthought. And typically we might do that, for purposes of developing maybe an interactive console, right? So we've said, hey, I've coded up my API, and I've kind of almost like locked myself in and committed myself to kind of how my API is going to behave. And now this is what it's going to be. Well, we've just spent the last 10 minutes talking about how important it is to be able to do it from the right-hand side first, which is saying, here's the contract. let's think about what that interface and that behavior of that API is going to be, and let's work from that first. And so, but at the end of the day, we want to be able to implement that API. So we need to have that machine readability. So this is where it's important for a specification to have both human readability and machine readability. Human readability because you want to start from the right-hand side and be able to kind of whiteboard an API and develop that contract or that interface so that people like Ole and I are able to have that conversation, as we just showed. And then on the left-hand side, at the end of the day, I'm going to want to now start developing and implementing my API. So you want to have that machine readability so that you can actually now start to develop your server-side code snippets or maybe some API clients as well. So it's very important today to have an API specification that is both human readable and machine readable. And so that's why we actually, we looked out there and we found that the spec called RAML, the RESTful API Modeling Language, next slide please, was a great spec for fostering best practice API design. So it stands for the RESTful API Modeling Language. And it's a really simple way for defining the API. And it's like I said, it's got that great human readability aspect of it, but it also has the tools that allow machines to be able to digest it, either maybe through, if you want to generate your Java code, JAX-RS code generator, or maybe some various client libraries for the consumer end. But the RESTful API modeling language is that specification that we believe is going to be able to foster this best practice API design, this API-first, interface-driven design paradigm that we feel is going to be very, very important going forward. So I think, and the next slide is, I think it's time for me to show you a bit of a demo. Is that correct, Lorinda?
Yes, that's right. We'll pass presenter to you.
Okay, great. So let me just show you an example of, so can you see my screen okay?
Yes.
Okay, great. So let me just show you an example of what, I mentioned, what if we could whiteboard an API, right? What would that look like? Well, here's an example of what we believe is a pretty good way to whiteboard an API. And so what you're looking at here is a tool in our Anypoint platform for APIs. It's one of the tools within our API portal for our Anypoint platform for APIs, and it's called the API Designer. And it literally is that whiteboard environment. And in it, you have a canvas over here, which is this black part. And then you have on the white part on the right-hand side, which is this kind of like an interactive documentation console, which will get auto-generated, as you will see in a few seconds. And then over here, you have a few kind of helpers to kind of guide you along the way while you're whiteboarding the API. I like to call it my whiteboarding assistant. So let's quickly, whiteboard an API really quickly and just see how easy and simple it can be. So, in the spirit of staying current, we have the World Cup going on today, right? So this whole month, and so I'm a fan of football, so I'm going to create a World Cup API. So let's do that. So let's go ahead, and I'm just going to now create a title called the World Cup API, right? And now all I'm going to do is I'm going to go down here and click on version, where it gives me a version already. And I'm going to go on and I'm going to give it a home to stay, so the base URI. Now what I'm going to do is I'm just going to create a very simple sort of, you can think of it as a resource structure. And so all I'm going to do is I'm just going to say resource. So I just have to go back in here. I'm just going to click on new resource, as you can see over here. So when I click on that, it kind of auto-populates a new resource for me. And so I'm just going to call that right now. I'm just going to call that countries. And so, all the countries in the World Cup, right? We want to show, this resource is going to be able to say, if I call it, I'm going to get a collection of all the countries that are participating in the World Cup. And I'll just kind of say, okay, well, I'm going to have a get method for that resource where I can then say something like, retrieve all participating countries, right? And then that was my little description. And then what I would do is something like, oh, you know what? When I'm calling this collection, I might want to sort the way I want my results to come back. So let's add a query parameter, right? So maybe I'll say something like, I'll add a query parameter. I clicked on query parameters, and all I'm going to do now is I'm just going to create a query parameter called sort by. And all I'm going to say there is, well, let's give it a description so people know what that is. So I'll say enter field by which you'd like to sort by. And, I have options here, so I could actually specify maybe a type, so I could actually say type string or type integer or something like that. I could say whether it's required or not. And in this case, I'm just going to give it a value of an enum, and I'm just going to say, I want to sort by FIFA rank and the number of titles that country has won, right? And maybe the second thing I might want to do is I'll say order, and I would say something like, I want to order in terms of ascending or descending. So in terms of like FIFA rank, the highest to lowest, or titles, the highest to lowest titles. So I'm going to pause here, and I'm going to go to the right-hand side and just kind of show you what's happening. So as you can see, it's auto-generated itself, and we can see, okay, if I click on the get, it's going to tell me, okay, well, here's a description, and here's a query parameters that you're going to need to pass, right? And I don't see any responses. So let me quickly go ahead and type some responses in, like just to show you what it could look like, right? So I go back, and by the way, this language here, this specification is the RESTful API modeling spec. And this is, if for those of you that are experienced in YAML, this is basically a restriction of YAML. So it's basically a YAML. So that's why it's so easily human readable. So that's that simple. Okay, so let's go ahead and add a response. So I'm just going to click on responses over here, and I'm just going to say, okay, well, for a 200, it's a successful response. I'm going to add in, let's say I'm going to add in a body. And maybe that body might be like a JSON response, right? And so I would say, okay, let's add in a JSON, specify here, and I might want to add in a schema. So, we have tools where, let's say, if you want to be able to kind of validate your data based on a schema, you can when you're having, let's say, a post, you can input that into your schema, and at runtime we have some tools that will be able to kind of send you a positive or a negative response based on whether your input parameters follow the schema or not. But in this case, let me just go ahead and do an example. So here I go. I'm just going to put in a quick example of what a response could look like. And what I'm going to do is I have a pre-prepared example that I'm just going to quickly paste over here. And so that's going to look like this right here. So I'm just going to post this example. Okay, so this is a JSON array here. So what we see now in responses is for a 200, if I was to query this collection resource of countries, I would get a bunch of countries back, So I get Brazil and England and Portugal and Argentina. And you can see here that FIFA rank and titles. So cool. So that's what my API looks like. So now, the next thing is, hey, I want to kind of, this is a whiteboard, right? So I want to kind of be able to show people, hey, look, this is what I want to, I want people to kind of start playing with it. Like I want Ole to come in and try it. I want him to tell me what he thinks, right? And so we have this, this mocking service that if I was to just click on, and basically what it does is it creates a server-side proxy and in this tool, and so it actually makes a real call to the service right here. And the results will be based on the examples that I've actually put down over here. And Ole will actually get into some more dynamic examples later on, I believe. So let's just show you what this looks like right now. So this is like I'm in the design phase, and I'm just going to say, okay, I'm going to quickly test this out, and I'm Ole here, right? So I'm going to say, okay, well, let's say I'm going to choose my parameters, right? And I'm just going to say get. I'm going to click on it and see what happens. So what happens? Well, let's see here. Okay, well, that was a request URL. This was the status that came back. So 200, that's a good thing. And so it actually made a successful call to the server. And here you go. Here's my body. So here is my API response. So imagine that I'm just like socializing this with like a bunch of business users and developers. I'd be able to like in real time kind of show how this API behaves and actually real time make some changes. So I don't know, Ole, do you have any requests for me? You're looking at this right now. What do you feel so far? How does this look to you?
I think it looks pretty good. I guess what I would request next is maybe to add like a child resource to countries. If you could do that pretty quickly.
Yeah, I could. So easily what Ole is saying is, look, let's go ahead and add some child resources, and just like this, I just have to go and click on new resource, and I was able to easily add in a new resource here, and maybe I'd have a conversation with him and say, okay, what are you looking for? And he might say, well, I want to be able to identify who are the players in that country, right? And so, or maybe I want to be able to say, I want to query by country name or country ID, and when I do that, I want to have a get method, and so I kind of insert a get method, and so on. And so, in developing this API, what it actually looked like, and I'm not going to show you the development of the API, but what I'm getting at is we kind of go through this iterative process, and we kind of come to this final stage here, where this is what the World Cup API looks like here, right? So we have countries, and Ole requested for a child resource, and so I gave him a bunch of sub-resources here, so you can kind of query by country name, or you can actually say who are the players in Argentina. So like for all the countries, give me Argentina and give me the players in Argentina, and give me, or maybe he came back and said, hey, I just want to query who all the players are. And within that, I want to know, all the players in the World Cup. So it kind of gives me a example of like all the JSON of, okay, here's Cristiano Ronaldo, here's Steven Gerrard, here's Neymar, and there's a 200 response for that. And if it's a 202 or a 302, there's different sort of descriptions that have been populated so you can see. And by the way, he can also try this over here too, right? Because we can also mock this API here, and so Ole would come in, and you'd kind of just have a look and enter whatever parameters would be appropriate, and kind of look at it and see, okay, here's a 200 response, and here's the players, right? And kind of we'd have a feedback process. We'd be dynamically talking about this as we go along. So this is what the final API looks like. It's as simple as, so we have about countries. So the view on the left is the RAML view, and the view on the right is the interactive console view, and they're both doing the same thing. Now, one thing I'd like to point out is I mentioned that being able to model your API consistently, and so I'm not going to dive too deep into it, but just want to plant the seeds that you are going to see a lot of patterns occurring. So patterns at the resource level, patterns at the method level. And so what I've actually done in this API to make it so clean and consistent is I've actually used two RAML archetypes one is called a resource type, and one is called a trait. And so a resource type is for encapsulating those patterns and defining those patterns that occur at the structural level of the API. So things like what are the, we will have collections. And so like players and countries will kind of have similar properties. Maybe they'll both have posts and get methods. So I have defined a resource type called collection over here, and they both have get methods and post methods. And within that, I'm able to parameterize these methods so that when I'm invoking them, when I'm applying these things, these resource types, I'm able to pass whatever parameters are contextual to where I'm calling it from. So if I'm calling it from where I defined players, I'm able to pass parameters that are appropriate to the players collection. Or when I'm calling it from countries, I'm able to pass parameters for applicable to the countries. And so, this is an example. So countries, all I said was type, collection. So, resource type, collection. And I had to pass a couple of parameters. One was for the response payload and one was for the request payload. And so I was able to sort of include these files from external sources. And so this is one of the strengths of RAML is you're able to kind of identify patterns, define patterns, and then also kind of encapsulate those patterns in foreign locations so that you can, define those sort of pattern variables, I guess, in foreign locations so that you can make it easily collaborative and shareable. So imagine this is like an include file from your local Dropbox in your enterprise or from your SharePoint. So as a team of developers that are making an API, you're able to kind of just go ahead and quickly kind of share certain standards. And so long to short, we're able to define this API with patterns in mind so that we're able to kind of create a nice, consistent experience. Ole, any other comments before I shoot it over to you?
Well, I was just going to get back to what I said earlier. So this is the tool that we've been using in a couple of projects. So basically where we've been, a couple of developers sitting around the screen and building the API interactively and, just adding stuff and traits and resource types and parameters and everything. And since the visualization you get to the right is a way that many developers are very comfortable way of looking at APIs, REST APIs specifically, it makes it for a very quick, and gives a feedback tool for actually building those APIs. So it's extremely collaborative in the sense that you can really sit together and build the API, and it's just as simple as you showed it here.
Great.
Great. Thank you, Sumit. So should we turn over to you now, Ula?
Yeah, sure. So if you make me presenter, someone makes me present. Okay, awesome. So thanks, Sumit. So I want to continue. So let's say we have, spec'd out our API, the World Cup API. Maybe we're still somewhere in the middle of that. But one of the great things that this API design first approach allows you to do is that you can, once you have the spec, you can start doing multiple things in parallel in the actual development team. So I want to highlight that a little bit, and I'm going to show you some examples as well. So first of all, what you can do is obviously you can take the RAML spec to generate server-side code and generate stubs in JAX-RS in this case, and you can use that as a basis for your API implementation moving forward. The second thing is QA can use the spec and for creating both the virtualized version of the API, which is like like the mocking we saw here, but with much more richer functionality, which is valuable further down the road. I'll show you that in just a little while as well. And of course, creating functional tests, because initially, if your server implementation of the API isn't available, it's going to be hard to create a good functional test suite at the API level at least. And you can use the virtualized API to do that as well. And then if you're building a client, in JavaScript or a mobile client or whatever, you can do the same thing there. You can use the spec to generate the client libraries, and you can use those in your client application. And the client application can, of course, also use that virtualized API, and that's a really powerful way of simulating different types of behavior. You might want to simulate errors. You might want to simulate slow response times. You might want to simulate different types of responses to the same request. Basically having a much more dynamic virtualized service or mock service than what you can get in the RAML designer that we saw here. And of course, moving forward, you want the client application to interact directly with the API implementation, and then you would tie all that together, hopefully, with the continuous integration deployment environment, where you basically build and test all of these things at once. And that's very much facilitated by having that spec to start with, which allows you to create all these artifacts in parallel and tie that together. And then, of course, ultimately, you'll want to push that into production. And if you're adventurous, you can do a continuous deployment and do that as well. And you could even use the functional tests as production monitors of your backend APIs if you wanted to. So this is so this is one of the things I really like about doing a spec first approach to building your APIs. And just to give you an idea of how this looks in the actual tools, I'm going to show you a little bit code and also a little bit in SoapUI, which is of course a great tool to use to create both functional tests and virtualized APIs in the line of what we've been seeing here. So let's just I'm just going to jump to between different tools here. So basically here, this is the development project I have running in my Java development environment, IntelliJ. Here's the RAML file. This is a World Cup RAML file that is similar to the one that you saw that Sumit showed you. This is not one using the resource type and trait constructs, but more having a flat structure. But here you can see all the resources and sub-resources and example responses and everything. And in the RAML toolset, there is a plugin, basically a Maven plugin, that you can configure to generate skeleton JAX-RS interface. So when I run that tool, I'm not going to run it here because it's basically doesn't take any time to run, but I'll show you what it generates. It'll generate these annotated interfaces in the line with the JAX-RS specification. So for the countries and for the players APIs that we saw in the RAML file that Sumit showed us, it's going to generate the corresponding JAX-RS methods and annotations and all that. And then in my project, all I had to do was implement them. I started out with an empty implementation, And I'm using something called Drop Wizard, which just allows me to wire this together. It's, as you can see, it's just like, I don't know, how many, 67 lines of code together with the implementation classes. And then I can just run that locally. I have it running now. And if we can, we're not going to see much, but just to prove my point, I can make a call now to the APIs, the empty implementation, just to the GET requests from my web browser here, and then of course I can start building, implementing these APIs, and that's all the boilerplate stuff with the annotated interfaces and all that stuff is of course generated by the tools, thanks to the specification, the RAML specification that Sumit showed us. So the more effort you put into building that, the more you'll get ultimately when actually implementing the API. So that's very quickly looking at the code generation. So the next thing is, of course, I want to show is SoapUI. SoapUI, as I hope you know, is a tool which you can use for API testing, load testing, functional testing, mocking or virtualization, security testing, all kinds of stuff. We're just going to focus on two of that. So I'm going to create a new project here in SoapUI from that RAML definition. So I'm just going to browse directly. This is the exact same file, if I can find it. Here we go. And I'm also going to generate directly a mock service and a skeleton test suite for that API. I'm going to save it here. Okay. So now it's, so also I'm showing, these are features in the upcoming 5.1 version. So if you're a SoapUI user, you're wondering where did that dialogue come from, it's something you need to look forward to in the upcoming release. So what I have here in the SoapUI project is, first of all, you can see the API itself with the different methods and the sub-resources, and I can open up the requests. You can see it generates forms for you using the enumerations that Sumit had put in the RAML file. I can make a call to since I have it running here in under Drop Wizard, I could start calling that from here. I just get empty responses back. I'm not going to do that for now. It's also generated a mock service, which is in SoapUI basically is a way for you to create a dynamic simulation of that API. So what Sumit showed inside the RAML designer is a very static approach to mocking, which is great during the prototyping phase. But if you want to start building clients or building functional tests, you're going to need a little bit more dynamic responses. So for example, here I can see that for the GET request for countries, currently there's one response, which is the example that I had that was in the RAML file. I can easily let's create some more responses here. JSON. And then, of course, I could change the content of each of these responses to contain maybe an error or a different number of let's just remove some of them here. Like that. This one we can remove all of them. This will be an empty response. And then we can tell basically SoapUI, so when it receives a request, we can tell it to sequentially move through these responses. But we can also, if we want to have that a little bit more dynamic, we can create a script using Groovy that selects which response to return. So that script could look at the request parameters, query parameters that Sumit was showing, and basically choose a response based on the incoming request. The scripts could do any kind of logic. They could pull data from a database. They could, generate random data to insert into the response. So the mocking in SoapUI is really taking the static mocking you have in the RAML designer to the next level, allowing you to create, a simulation of your API. And all I have to do here is I can get this running immediately. Let's just start it running on port 888. So now I have the mock service running inside SoapUI. And the next thing that I might want to do, so I've done the mocking part. This mock service could now be used by client developers who are building my mobile client or any client, but it could also be used by testers that want to build a functional test suite. And if you remember, when I imported the RAML I asked it to generate a test suite. So it generated a test suite and a test case for each of the resources and child resources in the RAML file that we defined. And then each test case, it added a request for each of the actions for that resource. So for example, for the countries, we have both a request for the GET request, but also we have a request for the POST request. And here you can see also that the POST request contains the example JSON that was in the RAML file that Sumit showed us. So let's just point this to run against the mock I have running in my server locally here. If I run that, you can see that I'm getting different responses. And if you remember, I set the dispatch mode to be sequential. So I'm getting the three responses I had defined for the country's resource. It's just sequentially going through them. I could, of course, set in any values here, but I haven't currently configured my mock service to take those in account in any way. And if we look at so one thing we might want to do here is add some kind of validation, add like what we call assertions. An assertion basically checks that, the response contains some kind of data or is in some well-formed way. I can just, I don't know, they're going to be pretty loose, but still, let's just add assertion that we want the response to contain the word Brazil. It's going to fail once because this is giving me the empty response back, but then it's going to succeed for the next two responses, if you remember, where I still left the response, JSON response containing the Brazil country in there. And in a similar way, I could start adding, building a functional test suite. And when my server-side developers in my team have started deploying, say, okay, we've actually implemented the country's resource, and we've deployed it to our server. All I can do here is I can just change my tests to use that deployment instead. So I can basically just, point, okay, now instead of running against the mock, run my test against the actual deployment, the deployed API. So I can, so what this basically has helped me do is thanks to the virtualized API that I could create up front, which is with dynamic behavior, I could both build a functional test case, but I could also have used that for building a client application against the API. And I am rushing really fast here, so I'm going to go back to the presentation. That was the demo. So yeah, so just to reiterate, so what we did, we had the RAML spec, we generated the server-side code, which helped us start on the API implementation. We also generated a virtualized API and started creating some functional tests, which we could have used. We ran those tests against the virtualized API, but we could, of course, run them against the API implementation moving forward. And I apologize for talking so quickly. Hope that you followed along. Sumit, I'm going to ask you here, because I know one thing is that might be interesting here is that once your API has actually been deployed and you want to start playing around with your API and see how it interacts with APIs, I think Sumit has a little bit to talk about there. So Sumit, the stage is yours again.
Yeah, absolutely. So, thank you, Ole. That was great. Ole just showed, some of the more dynamic things you can do with once you have that interface defined. And another thing that you can do is, typically when as developers, we're trying to understand an API, right? So we can go to the user console, which is, on the right-hand side of the designer, which is what we just showed you over here. By the way, can you see my screen, Ole? It's good?
We're looking at the API playground slide currently. Should we?
Oh, got it. No problem. That's perfect. So, when we're trying to understand APIs, we may kind of read the documentation, right, static documentation, or we'll go to the interactive console as Ole was showing, and I was showing around the kind of how the get methods are structured and all that. And then Ole was showing the next step, which is, hey, let's dynamically mock this up. And I'll take this even a step further, which is, look, I want to start to even understand how this API works and is related in context of other APIs. So you're not looking at this API in and of itself. And this becomes really interesting because at the end of the day, everything we're building today is a composition of various APIs, right? And so imagine you had some sort of a playground in which you're able to kind of imbibe all these APIs together into a single environment and start to tinker with them together, all talking to each other. And so it's about kind of taking discovery of an API and understanding of an API to a whole new level by experimenting with it in context of other APIs. And so we have this product called the API Notebook, which kind of helps facilitate that. And so if you don't mind giving me show screen, okay. So let me walk you through a quick scenario. So the API Notebook, by the way, is it's available. You can have a look at it as part of this part of the RAML toolkit. It's called. You can see it as part of our Anypoint platform. It's one of the features of our Anypoint platform as well within our platform's portal, and it's a place where you can kind of create interactive Java. JavaScript snippets, and they're runnable. And so think about it as you've got all these RAML files, you kind of pull them in, and you create JavaScript objects, and you're able to kind of play with them. And so let's say I had a scenario where, in the context of the World Cup API, now let's switch hats and say I'm developing a database API, or I'm saying I'm going to have a sports database, and in that I want to be able to say, look, here are all my athletes. And for the people that are playing football, I want to be able to post certain athletes to that. And I want to work with this in context of the World Cup API because I want to take all the players from my World Cup API and I want to post them to the sports database. So I'm going to show you how to do that using our notebook and how you can tinker with that using our notebook environment really easily. So all you need to do, so what this notebook environment is, it's really simple. Basically all you have is these little code cells or text cells, and all you need to do is just sort of use some commands that easily allows you to kind of create that one of those clients. So all I'm going to say is something like API.create client, and I'm going to create a handle to my World Cup API that we just talked about. So I'm just going to say World Cup API, and then all I'm going to say next is I'm going to reference where the RAML file lives. So it's an HTTP reference. Press enter. And all I've done here is I've just said, okay, good. I've just created a client to my World Cup API. And I just have to press enter one more time. Interesting. Let me just try this again. So okay, so I'm going to say World Cup API, and I'm going to reference where the RAML lives. Okay, there we go. It just created the client. Sorry about that. And then the next thing I'm going to say is, okay, hold on one second. I'm just now going to, I just created this API with the wrong RAML. So what I'm going to do is I'm going to delete the cell. I'm just going to do it one more time really quickly. So API dot Okay, so it looks like there's something that's not working for me here. So let me go straight to another demo here where I'm going to show you with my Twitter API and GitHub API talking to each other. So what happens here is I have a Twitter API that I called in, and basically here there's the handles the Twitter REST API, and here's where the RAML file was defined. And basically what I'm going to do is I'm going to say, okay, I'm going to authenticate that Twitter client by saying API.authenticate. I'm going to now, so I've created a Twitter handle. Now I'm going to say I'm going to create a GitHub client as well, because what I'm going to do is I'm going to query my Twitter API and ask for 20 tweets that I just tweeted, and I'm going to post those 20 tweets to a GitHub gist that's going to be private. So all I'm doing here is what I did was I created different cells. I said a text cell, I put the text in, code cell, I called the Twitter client, authenticated the Twitter client, called in the GitHub client, and authenticated the GitHub client. And here I'm calling the Twitter APIs method that'll basically get my 20 latest tweets. And then I've got the results from that tweets, and I'm going to put those results into the GitHub API. This is where I was referencing how you're working with APIs together. So I've taken the results of this Twitter API, and I'm going to pass it into my GitHub API right here. And then what the final command I do is I say, okay, let's open up the location of my gist. So all I'm going to do is and one of the cool things about this environment is that you can play it. You can so you can kind of make it like a runnable script. And the cool thing is that this is all in Markdown. So you can actually easily share this. So as you can see here, I just switched the view to Markdown. So at the end of the day, it's all Markdown. And you can, here is your JavaScript code that's embedded within that Markdown. And this whole thing is just basically a Markdown piece of text. And you can share it. So you can share it to GitHub. You can clone it. So if you're like if you like what I did, you can actually clone it. And you can actually use this in however you want to use it. And you can actually plop it into your code. So what I'm going to do right now is I'm just going to press play. And when I press play, it'll run each cell. And before I do that, let me quickly make a tweet of something. I'll do that once it presses play. All right, so it's going to authenticate me pretty soon. There it is. So it authenticates, and I'm going to authorize it. And it's going to have me authenticate to my data. So let me quickly tweet something. I'm just going to tweet something that says, having fun with the API notebook. So I've just tweeted that right now. And I'm going to go back to my notebook. And, okay, it's at the step where it's authenticating the GitHub client. And it's going to create the GitHub gist. And there you go. And it just created this gist. And you can see here, having fun with API notebook was this tweet that I just posted. So it shows you how it works. And so I was able to dynamically, really easily just create a script that showed two APIs working with each other in this environment. So it kind of takes that collaboration and understanding of APIs to a whole new level, because I can do this with production APIs, but I can also do this with non-production APIs. If I was to mock them in a RAML API designer and set examples, I can actually use this environment to kind of mock APIs, and I'll get mocked responses back based on the static examples that I put in. So this is a very neat tool for kind of taking that exploration to a whole new level. So I'll stop right there, and Ole, I'll turn it back to you. I think we're done, but maybe there's any questions or learned, I'll turn it back to you as well.
I have a question while we're transferring this back to Lorinda, or to me actually. So the scripts that you showed here, can they be used in any environment, or can I embed them on my website or on my mobile app, or do they have to be run inside in the API notebook?
Well, at the end of the day, it's Markdown and it's JavaScript snippets over here. So wherever you want to use JavaScript scripts, you can actually embed it anywhere. So I would say yes, you could.
Great. Okay, we do have a question that's come in, and I think, Sumit, this is probably for you. Does RAML have any tooling support for validating a data model based on the RAML specification? So, for example, I want to validate an incoming post request containing valid data according to my RAML spec.
Yeah, we briefly touched on this in my presentation, but in RAML, I showed you how you could actually, when you're defining a response, for example, you could or an input parameter, you could actually specify an example, or you could specify a schema. And so if you were to specify, let's say, a JSON schema, you've got the schema defined, and we have a tool called API Kit, which basically at runtime will create the implementation of the API, and that tool will be able to then look at that schemas that you've defined in your RAML and be able to say, oh, okay, is the response, is the input, let's say for the post, is the input parameter in the body, JSON body of this input request making sense or not, and it'll validate it against a schema and send you a positive or a negative request. So yes, we can do that.
Okay, great. And we have another question that's come in from Priyanka, and I believe this is for you. Can we use the RAML project file in SoapUI? You showed a browser window. Can you talk about that a little bit?
So what you can do in SoapUI, there's a plugin for SoapUI, the RAML plugin that you can download and install in SoapUI, and that allows you to import the RAML specification. I guess that's what you mean by RAML project here. So you can import that RAML specification into SoapUI, and just like I did in the demo, and create, functional tests, do all the stuff you can do with SoapUI. Another cool thing you can do is you can actually generate RAML files with that plugin. So if you have a REST API that you've defined manually or that you've recorded, using the recording features in SoapUI, and you would like a RAML file for that, you can just, right-click the REST API and you do export as RAML, and then you can paste that RAML into the API designer that we saw here, and brush it up and add some examples and all that stuff. So the plugin, and it's freely available, and it really ties SoapUI and RAML together in a very nice way.
And just to elaborate on that a little bit, what you showed when you were opening up that browser window that showed the RAML plugin, that's functionality that's coming out in a couple of weeks. So that's part of our 5.1 release.
Well, yes. So the way I did it is something that's going to be in 5.1, but the RAML plugin that's available today for SoapUI 5.0 has the same functionality. It's just that the flow is slightly different. So if you're using SoapUI 5.0, you can search for SoapUI RAML plugin on Google. You'll find it. You can download it from GitHub and use it just in the way that I showed you.
Great. Okay, one last question. We have a question that says, how about multi-language support for the documentation in RAML? Do you support multi-language, Sumit?
If the question is, do we support, are there code gen tooling for creating code in multi-language? Yes, there's a variety of those already for server-side and client-side. I think, or if the question was, is there other formats that you can define the spec in? If that was the question, such as, I don't know, maybe XML or JSON, for example, I would say, the reason why we went with YAML, a restriction of YAML, why we believe in RAML as having that power of, that ability to do human readability is through that simplicity offered by YAML. So I don't think it's available in any spec. That would kind of defeat the purpose of RAML in that sense, because you're trying to achieve that human readability and avoiding that the dense cruftiness that would be there from other languages like a JSON or XML or something like that.
Great. I know I said one more question, and I know we're running out of time, but we have a couple of really good questions that have come in. So one more very quickly, Sumit. Can we define authentication process in RAML specs that's going to be used for the REST service, like basic auth or OAuth?
Yes, you can. You definitely can. You can consider that to be one of the patterns available through the RAML spec. So you have patterns at the structural level called the resource type, patterns that'll at more of the partial method definition type things like the traits, which will allow you to define behaviors of the API, and then you have patterns around how security is going to be applied for that API. So basic authentication, OAuth 2, RAML supports those patterns, which I did not get into, but happy to get into that at another session or call me offline. But yes, in short, yes, we can support different security pattern definitions.
Great. So we do have other questions that are coming in, and they are all great questions. We are out of time, but what we're going to do is follow up with everybody. We'll post these questions. We'll probably put them in the follow-up email that you all get or a blog post, and we'll make sure we get answers to all of the questions that have come in and that you all get to see them.
I have a call from 6 to 7, so if I do miss him, so if I miss him, I'll call him later.